We're going to do some stretching, shrinking, and reflecting of absolute values. And I've got them color coordinated again, and the parent graph is like the last video where f of x equals the absolute value of x. When you make a t-chart, you're going to use the domain -2, -1, 0, 1, and 2. That will be your x's because it'll be near the origin. And if you plug a -2 into the absolute value function, you get a +2. So -2, 2 would be, let's see, left 2 up 2 here. And then -1, absolute value of -1 is 1, so that's -1, 1. And then 0, the absolute value of 0 is 0, so you got your origin. And then you have 1, the absolute value of 1 is 1, because it's 1 away from 0 on the number line, so that's 1, 1. And then the absolute 2, and the absolute value of 2 would be 2, 2. So you have 1 here. All right, so each one of them will look the same when you're doing the parent. It's easy to memorize that you put a point at the origin and then you just do the slope of 1 this direction and the slope of -1 the other direction. So the parent graph can be put up really fast. Now, as far as the other ones, so this is my f of x. Okay, as far as the other ones go, if there is a remember A from the previous videos on the linear functions, if it is a number in front of the absolute value bars, instead of just moving something left, right, or up or down, you're going to need a t-chart to do that. And I've already got it filled out just to save time. But let's talk about what this is. If you have g of x equals the absolute value of, equals a times the absolute value of x, remember from the linear functions that if the a is outside the parentheses or outside the function notation, then it's going to be vertical. If it is bigger than 1, it's going to be a stretch. So my 2 is bigger than 1, so it's a vertical stretch. And the factor will be whatever a is, which is 2. They're going to ask you that. All right, so here I've written it down. It's just 2 times the absolute value of -2, 1, -1, 0, 1, and 2. The domain is the same there. All right, so 2 times 2, that would become a 2. 2 times 2 is 4. And 2 times 1, that becomes a 1. 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. And 2 times 2 is 4. So I'm graphing -2, 4. Left 2 up 1, 2, 3, 4. I'm graphing -1, 2 right here. 0, 0. I'm graphing 1, 2. And I'm graphing 2, 4. So my red one looks, I guess you could say, skinnier, doesn't it? All right, you can tell more about these when they're not straight lines. So that is considered a vertical stretch of factor 2. Now for the third one, we have a fraction, which was the a, the fraction, and it is negative. Now that negative means this thing is going to be upside down. This v is going to be upside down because of that negative. Keep that in mind when you see it. All right, because the a is outside of these bars, it's going to be vertical again. And it will be a shrink because this is a fraction between 0 and 1. And the factor will be 1/2. It's also going to be reflected in the x-axis, which this is the x-axis here. It's going to be reflected in the x-axis. That's the reason it's flipping over. I already put down the domain, the same domain as always. And then I've written down it's -1/2 times the absolute value of -2. So that's -1/2 times 2. Well, that is -2 over 2. -2 over 2 is going to be -1. And then here I've got -1/2 times absolute value of 1 is 1. Well, something times 1 is always going to be whatever it is, so -1/2. And half of 0 is 0. And then we have -1/2 times 1 again. So I've got -1/2 again. And -1/2 times 2. That's going to be a -1 again. They're symmetric, so these numbers should show up again. Look, 1. Let's see, -1, -1/2, 0, and then -1/2, -1. That would be correct. All right, so let's go, excuse me, -2, -1 here. -1, -1/2. So -1, -1/2 would be right about here. 0, 0. And 1, 1/2, and 2, -1. So we have this one, and he looks wider than the original, and I missed that. He looks wider than the original one. Let's see. Now this one was P of X. I forgot to write down that this one was Q of X. All right, so remember he is a vertical shrink. He's wider. He's reflected in the x-axis, and he's got a factor of 1/2. They ask you all that. They also ask you the domain and range. So let's look at those really quick. The domain is your x's, and if you're looking at the x's here, we've got x is greater than 0. All the x's, no, I'm sorry, x's are all real numbers. That's left or right, and these keep going forever in each direction. So all real numbers. And for the range, we're starting with the y's here and going up. So the y's are greater than or equal to 0. For the red one, Q of X, that's this one. Still the same domain. The arrows mean it keeps going each direction, so that's all real numbers. And your range, same thing. Y is greater than or equal to 0. So the y's are up here and up. And then on the last one, the P of X, domains, same thing, all real numbers. But the range is less. The y's are less than 0. So y is less than or equal to 0.